Let us you have to understand why sky is blue. Why not red, black? The light we see from the sky, it is sunlight scattered by a molecules in the atmosphere. The different layer of molecules are there. The ozone layers, okay? Different ozone layers. So, lot of protector are there. Lot of protector are there. And the molecules are much smaller than the wavelength of the nebula. That molecules are much more small as compared to the wavelength of the nebula. What is wavelength? We have to know the wavelength first. This is the x-axis, and this is the y-axis. The wavelength. Okay. Then it is starting from this x-axis and ending at this x-axis. That means that wave completes
'There are more molecules to scatter the light. Most of the blue is scattered away and leaving the ribbon. That is the reason sunset time, sunrise time, red color. That today's topic is the wave optics. And we have to understand what your that going and the what are the interference obstruction of the light and the what is interferometer and thin film interference. Light through a single slit, qualitative behavior. Quality of light when it passes with a single small hole. Double slit, what will happen? It's called Young's cleavage. Diffraction, optical resolution and the railing. Why is sky? Let us arrange some condition of the coherence. What is coherence? Wave optics. The field of wave optics studies the properties of the light depend upon the wave nature. What is the wave nature? If you see the graph here, here, this is the y-axis. So, the rate of increase of the y is the x4. Then if you start rate of increase of y with respect to x is this. And here rate of decrease of y. Now y is starting from here, this point, y start to decrease. So we are measuring some property of light, that is a wave nature. When the light was formed in particle is a dual wave and particle. Particle method. The models has to explain the phenomena discussed in the geometry. Let us look the Maxwell theory of natural energy. Maxwell has been theory when you derive, and the discussing image characteristics were over distance much greater than the wavelength. Geometric optics is extremely accurate. When dealing with the size comparable to a small and than the wavelength, wave optics is required. When dealing with the size comparable to the small than the wavelength, wave optics. So, why the that one property is wave interference of sound wave can be produced by speaker. The sound wave obstructed by different layers, barriers. So, if the three speakers like L1, L2 distance, and wavelength constructed wavelength that one when the waves are in phase, that we are not thinking there is a single light, the bunch of light. every segment of the line. We are not observing here the line or the every segment, but the so when the wave is placed, the maximum occurs at the time of execution. Nothing is placed, suppose we are considering a wave, that one wave is this is increasing at what rate, this is also increasing at what in same direction. It is not reverse direction. It is a right positive first quadrant, and the decreasing, it is also decreasing. Lambda is the wavelength. Okay. So both the are same phase. Then it is a constructive. It is a positive attitude. But this is the constructive. The consecutives have the equal wavelength. Look at the lambda, and they are in every phase angle. This is the time, this is the time, or pi, and y is the amplitude. So all three waves are in same phase, and it is called the constructive interval. So the total wave displacement at the listener location is sum of the displacement of the wave. What are this amplitude plus this amplitude? So if two waves are in phase, the sum of their displacement is clear. Now the disturbance. Let us put the maximum of one wave can coincide with the minimum of the other. How? Look, this wave at the first quadrant, first 90 degree, here is 90 degree, here to here is what? 180 degree, here to here was 270 degree, and here to here was clear. So if it is increasing, it is decreasing. It is decreasing. It is increasing. What disturbs it? So what we are getting is out of phase. We are getting the interference is disturbing when the wave are out of phase. If 180 degree out of phase, the sum of the displacement is the in consideration the amplitude. So general condition of interference for the consideration is that it is assumption that all are in phase, out phase, okay, but it's random. The part of segment of the wave are two waves can interfere all the following conditions are. What? Two or more independent waves travel over the last part of this company. The real source are the wave are brought together at the common. The wave must have the same frequency and must also have the fixed phase relationship. Thus, the over a given distance of time interval and phase difference between the wave dimensions such as of the point. The wave must have the same frequency and must also have the fixed phase relationship. Thus, over a given distance and time interval, phase difference between the wave remain constant.
such waves also required. Look, how to measure it? Interferometer. That interferometer is the based upon the interface of the reflected wave. The two reflecting mirrors are mounted in the right angle. For mounting, the third mirror is partially reflected, called the beam splitter. How it is? This mirror and this mirror. Okay. So wave 1, wave 2, and this is what? Beam splitter. It's coming like going from this. Then next can say the beam splitter, and this is the detector. Okay. So third mirror is partially reflected, all the beam splitter. Okay. What happened? The incident light hit the beam splitter and is divided into two parts. Part 1 and part 2. Clear? So, the wave reflected from the mirrors at the top and the right are recombined at the beam splitter. What way? After being reflected again from the beam splitter, most of the wave combined at the beam. The only difference between the two waves is that they travel different distance between their respective mirror and the beam. What will it? The path length. What? The difference L equal to 2L minus 2L. 2L minus what? 2L1 and 2L2 minus that is L incoming line. There is a difference. The beam splitter created two beam here and the beam splitter recombined the two beams. So the path length difference is related to the wavelength of the line. What happened? The N equal to del L by lambda. If N is an integer, then waves are in phase and produce a constant induction. If N is a half integer, the wave will produce the it's clear. So del L is the factor which is equal to wavelength. It is assumption of keeping the two mirrors at 90 degrees. Practically it is not there. For the calculation of the constitutive interference del L equal to my, but m for destructive numerator del L equal to m plus 1 by 2. M is an integer of both. So if the interference is constructive, the light intensity at the detector is dark, called the bright fringe. And if the interference is destructive, detector 0, the called it dark. So let us see the example what we are observing around the earth. The helium neon larger emit light with a wavelength of approximately 633. Suppose this light source is used in a interferometer and one of the mirrors is moved at a distance d, such exactly n equal to this,
bright fins are counted, calculated, n becomes this, and bright fins are counted. Now what is the thing is there? We know the 2L2 minus 2L1 is called del L. Okay? That is what? N of the lambda, and when the mirror move a distance d, the distance traveled by the light change is 2d. Back and front of the mirror, that del L is 2L2 minus 2L1 is equal to 2L2 minus L1, that is what? 2d. And what happens? That says del L is 2d and equal to n del n prime. And d equal to what? N by 2 half. Thus, what I am getting? d is half of that n. We know the n value, the problem. So, thin film interface. What is thin? As you may thin soft film rest on the float glass. What happened? The upper surface of the soft film is similar to the beam splitter in the interflow. Upper surface is acting like a splitter. So, it reflects part of the incoming light and allows the rest to be transmitted into soap layer after refraction and air soap interface. That air soap film, thin soap film, that is the distance of the layer. Then phase change, incident light, phase change. Then what will look? Both of that is the transmitted rays, and that the ratio of that is 1 and is 1.35 and 1.5 is last, and the rays is 2D become 2D, and air should be 1.5 air. Outgoing rays with the condition for rays travel through the different during combined when they are coherent because rays what happens? No phase change. Lambda into m equal to 0 light divided by n. But we get the wavelength change as light wave travel from vacuum into the and the number of extra wavelength is equal to 2m by lambda wave. Affected by the thin film undergo a phase change. That what happens, the number of the extra cycles traveled by the rays inside the film completely determine the nature of the interface. And if the number of the extra cycle n is an integer, there is a constructive interface. If the number of the extra cycle is half integer, there is a okay. Where is the n? Then it is a constructive. N by 2 is constructive. D equal to. So 2D equal to this constructive interface and 2D equal to this is the destructive. And what? Phase change. Only if in here less than in clean and less than substance below the clean. 1, 1.35, 1.5. So, thin film interface is case 1. Case 2, assume the soap bubble surrounded by air. There is a phase change at the top of the bubble. There is a no phase change at the bottom of the bubble. What happens? Since only one wave undergo a phase change, the interfaces are what? No phase change. The interfaces are what? Constructive interface 2D equal to this condition and destructive interface is this condition. Okay? Color and thickness of soap film. Consider a bubble formed from a thin and soapy film that looks blue when viewed at normal incidence. Estimate the thickness of the film. Assume the index of reflection of the film is 1.25 and blue light has a wavelength of 400. Also assume the film is also thin, that thinner films are not able to give constructivity. What happens? The interface here is a destructive, we consider m equal to 0. Then what will happen? 2D equal to this, then what number n will get? That is lambda blue by n film 2. That is what? 74 nm. D equal to. Let's put the chemical slit quantitative behavior. Light passes through the slit or opening like this. Small hole. And then after this, it's casting on the. As the width of the slit becomes closer, small, the wavelength of the light and the pattern of the slit, additional maxima becomes sufficient. Let us look. That is the slit, incoming light. Brightness region. Part B shows light intensity along the x-axis and brightest region on it. White that W
and outgoing wave. This is the computer portion of the computer.
If you draw the wave form, the wave for the so plane wave form and outgoing wave.
Learn the particular distance, then this is the L2, this is the L1, then total length is also 1 to get the this, and this is the D, okay, then this is the hypotenuse, it is 1, this is L equal to V by hypotenuse, and you get this. For constructive interface, B sin theta equal to A. What we got? We got del L. The del L is what? M lambda, where M is the magnetic property of which the spin with the 0 plus 1 minus 1 plus 2 minus 1. On the axis of the wave, we observe the bright fringe. For that, the light intensity will be large and the wave will be in phase at this slightest speed. For distracting, that d sin theta equal to m plus 1 by 2 lambda. That means what? M is decreased. We'll observe the dark field. M is decreased by the half. Clear? And we observe the dark field. Okay? That first spherical that is 0, second is 1, and third is like that M. And we will not be in phase and they strike this. It's not making line. Double slit intensity pattern. The angle theta that making the position of the intensity line move along this space. What is that? So angle theta, you see the at the slit 0 M and at this font, wave font, that is M minus 1, that is M plus 1, and third wave font, it is a M equal to minus 2 and plus 2, and the fringe area what? From this to this. Because distance between the adjacent bright fringe is h. How? B is the distance between the slit, as you have calculated earlier, and W is the distance between the slit and the slit. Okay, and h is the distance between the adjacent bright fringe. Let us look. Each bright fringe corresponding to the different value of m. A negative value of m indicates that path to those points the slit from the lower slit is shorter than the path from the upper slit. For m equal to 1, sin theta equal to lambda by 2. When m equal to 1, sin equal to lambda by 2. And since the angle is very small, we can see sin theta equal to and theta equal to lambda by 2. So between m equal to 0 and m equal to 1, h is equal to w tan theta. H is equal to w tan theta. And that for a small angle, sin theta equal to theta, tan theta equal to theta, then what will happen? It is approximation, h is equal to w theta. And what is this theta? Theta is the lambda by t. So, interference with the monochromatic light. Light is single frequency is called the monochromatic, you know very well, black and white. And light source with a variety of wavelengths are generally not useful for double slit interference experiments. The bright and dark fringe may overlap or total pattern may be washed out some of bright and dark. So bright and dark figure will be fitting. No bright and dark figure. Make it differentiate. Measuring the wavelength of light. Young double slit experiment shows that light is wave also give a way to measure the wavelength. Suppose the double slit experiment. In the figure, this, what you got? H is given 1.5, W is given 1.5, and D is given 0.4. What is the wavelength of the light? From that formula we know the solution that lambda equal to h by dw, that is 400. Frequency difference slit may be narrow enough to do dimension, but not so narrow that cannot be treated as a single slit. Assume the single slit has a width of W and light is diffracted as it passes through the slit and propagates through the slit. This is the point. Single slit. Incoming light. White W. Okay? Then what? The key of the calculation where the occurs is measured to what is this? W by 2. Okay? A1, A2, A3, A1, A2, A2. Both wave font. All points across the slit act as a wave source.
and different web interfaces. Firelight will divide the screen into two parts. What happens? One of point is each part of the screen satisfy the condition of the destructive interface, and web from the all similar set point will be interpreted destructively. And what will happen? That del L equal to W by 2 sin theta. And W theta by 2. Destructive interface will produce a dark field, and single slit analysis dark feature. Conditions for the destructive interface are W sin theta equal to plus minus m lambda, where m equal to 1 and plus minus m. The negative sign will correspond to the pins below and center of the. So, single slit analysis, right field. There is a no simple formula for the angle at the right field. The intensity of the screen can be calculated by adding up all agencies. There is a central bright fringe. Central bright fringe called the central maximum. Central fringe is about 20 times more than the intensity of the bright fringe and either side. The width of the central bright fringe is approximately the angular separation of the first dark fringe on the either side of that is 2 lambda by W. The rays is the maximum and this is the minimum. First minimum, that is 1.2. that this value, theta value is 1.25, this is the theta, and this is the intensity y, and this theta value is 1.2 lambda by 2. Clear? So, are sufficient R they can be seen as separate values for if the source are too close together, so much appears single. Overlap. Understand? Overlapping. It will see the condition ABC comparing. Okay. Source will be resolved as to this thing. The line is angular greater than the angular range of the signal. So, if the two sources are equally far apart, they can overlap the respective values. If the sources are close together, they directly want to overlap. There is a mistake here. So, okay. As to these things, if their angular separation is greater than the angular rate of light, this is all always negative. For the circular opening, ready criteria for the angular rate is 1/2. Let me see. We have to calculate theta first. Theta will get almost very small, so it becomes the h by L, the theta mean. Okay, and we can calculate the h like this. No problem. So why the sky is blue? We are told